Hi everyone, this will be an overview on how to determine the number of possible stereoisomers for a compound. I think it's really important to articulate here at the outset that sometimes there are little exceptions to how we calculate this. It's not always the case that we will use this rule to calculate the number of possible stereoisomers. This rule works well when we have asymmetric centers, but there are some exceptions / odd cases that we should know, and I will be making separate videos on each of these so that you know how to adjust your calculation and your problem-solving process accordingly. Okay, now in general, if you did not have these weird funky exceptions, we can use this rule here, 2 to the n plus the number of easy double bonds, where n is equal to the number of asymmetric centers, and then easy is equal to the number of easy double bonds. You would count the double bond as 1 towards that count. So for example, here, there are 2 asymmetric centers. This double bond within the 6-membered ring is not an easy double bond. We would say 2 to the 2, which is 4 possible stereoisomers. In this structure here, we have 1, 2, 3 asymmetric centers. So we start by saying 2 to the 3, plus the number of easy double bonds. We scan for those. This is an easy double bond. We have one of them, 2 to the 4, which is equal to 16 possible stereoisomers. In this example here, we have one asymmetric center, one double bond that could be classified as E or Z, one asymmetric center, one easy double bond, 2 to the 2, which is equal to 4 possible stereoisomers. In this molecule, we have 1, 2, 3 asymmetric centers. This double bond, however, cannot be classified as E or Z because you have 2 of the same priority atoms / groups on this side of the double bond. Therefore, it's just 2 to the 3 asymmetric centers, which gives you 8 possible stereoisomers. Now, again, there are exceptions to this, which I'm going to talk about in subsequent videos, so definitely watch those if you want to make sure that you know how to solve these questions and get to the correct answers in those funky cases. Those funky cases could be in the case of cyclooctene, where we have meso potentially affect our number of stereoisomers. And also when we have compounds that lack asymmetric centers, but still have stereocenters, so we get different cis-trans possibilities that can result in multiple stereoisomers for a given compound that still, again, is lacking asymmetric centers.